Since there are so many variables on our transfer step, it's going to be extremely important for us to be able to verify transfer efficiency to confirm that our proteins have left the gel and have bound to the membrane so that we can continue with the technique. There's basically 3 different ways to do that, and we're going to talk about all of them so you can make your decision on which method is going to work best for you. So the first one is a very simple and direct method, which is simply to look if your molecular weight marker or protein ladder has transferred from the gel onto the membrane. However, I'm going to let you in a little secret. All the proteins that are chosen to be part of a molecular weight marker were carefully selected. Those are proteins that we know transfer very well. So while having your molecular weight marker show up on your membrane is an indicator that your transfer worked, is not a guarantee. So we need to be a little careful with that one. All right, so if that's not a guarantee, what else could I do? Well, perhaps we could think about trying to make sure that the proteins have left the gel. And a way to do that is to stain the gel with something like Coomassie after the transfer. Let's think about that. Well, if Coomassie is known to stain proteins in the gel, what we would want to see when we stain that gel after the transfer is nothing, right? All the proteins should have left the gel. Well, let's not go that far. We're always going to have a little bit of protein left behind. And matter of fact, if we don't, we have probably overtransferred. But it's not only that. The thing is, proteins may have left the gel, but never really bound to the membrane. They might have precipitated in between. So they left the gel, they're not on the membrane. So once again, staining your gel with Coomassie after the transfer is an indicator of a transfer efficiency, but not a guarantee on how efficient that transfer was. So again, we might want to think about a different option. And the most direct way to evaluate how efficient my transfer was is to actually stain the proteins that are present on that membrane. So we can use something like a total protein stain to address that. There are even some more advantages to that. If I do use a protein stain directly on the membrane, not only I can address transfer efficiency, but I'm also going to be able to see if there are any other artifacts present, such as an air bubble that may have affected my transfer and ultimately influence my final data analysis. In addition to that, a total protein stain might be used as an internal loading control, and we're going to talk about that in future courses. But for now, let's think about our total protein stain options. One of the most popular total protein stains is Ponceau. Ponceau is a stain that I can use directly on my membrane, and it's going to label virtually all the proteins I have there. However, it binds very strongly to the proteins on the membrane. And if that stain is not completely removed, a lot of times it will affect the primary antibody binding downstream of our Western blot protocol. Not only that, but it has a very narrow linear range. So if in the future we do want to use it as an internal loading control for normalization, it may not be our best option. Not only that, but Ponceau is not necessarily easy to image in a lot of Western blot imagers. So to record that data and keep it for future use may also not be very straightforward. Revert is a total protein stain as well. However, it doesn't bind that strongly to the proteins on the membrane. Because it binds through non-covalent bonds, it's very easy to fully remove revert from our membrane, meaning that it's not going to interfere with the primary binding downstream on our Western blot protocol. Revert is also easily imaged on the 700 nanometer wavelength, so if you do want to use it as an internal loading control, that's pretty straightforward, and it also has a very wide dynamic range, so once again, facilitates its potential use as an internal loading control. If you do want more information on the use in internal loading controls, please refer to the other LIMDA U courses that we have on that topic.